Hey everyone, welcome back. This is lesson 6.3, Dividing Polynomials. The objective for today, you will be able to use long division and synthetic division to divide polynomials. Your vocabulary for today is synthetic division. Polynomial long division is a method for dividing a polynomial and another polynomial of a lower degree. It is very similar to dividing numbers. Here we see the parts of an arithmetic long division and a polynomial long division. Notice that they both have a divisor, they both have a quotient, they both have a dividend, and often they have a remainder. Okay, so before we start using long division to divide a polynomial, let's just review what we know about regular division. Okay, so if I have 12 divided by 277 divided by 12, I say, okay, about how many times does 12 go into 27? And I say 2. So 2 times 2 is 4, and 2 times 1 is 2. And then we subtract. 7 take away 4 is 3. Bring down a 7. 12 goes into 37 approximately 3 times. 3 times 2 is 6, and 3 times 1 is 3. Again, we subtract and get 1. We used to say the answer would be 23 remainder 1. Now we say 23 and 1/12. Or you could actually put an addition sign in there, and there's your final answer. And then we know we could go back and multiply 23 times 12. 23 times 12, 2 times 3 is 6, 46, and then that would be 23, 6, 7, 2. 276 is not the same as 277, but we have to add our extra 1 in. Plus 1 is 277. So we're going to do the exact same thing using long division to divide. So let's go ahead and set that up. The first thing we're going to do is say y minus 3. And then, we don't need that, we're going to go ahead and divide. But before we divide, we have to put this in standard form, which means our exponents go from largest to smallest. So let's get started. We start out with 2y to the third. And then next we have a negative 1y, so we're just going to say minus 1y squared. Notice that we don't have any y's in here, but we need to go ahead and keep a placeholder for that, so we're just going to say plus 0y, and then plus 25. All right, so now we can start dividing, and what we want to look at is our first term here and our first term here. And what number can y multiply by to get to 2y to the third? Well, I know that that would be 2y squared. And 2y squared times y is 2y cubed. And then minus 2y times 3 is going to be 6y squared. All right, and now I'm going to subtract. So remember, when I subtract, I have to change the signs on both pieces. So instead of subtraction, it's now addition on this second 6y squared. All right, so 2y cubed minus 2y cubed is 0. Negative 1y squared plus a positive 6y squared is actually a positive 5y squared. All right, so now we're going to bring down our 0y plus 0y, just like we did before. And we're going to look, what number if I multiply y by to get me to 5y squared? Well, that would be 5y. All right, so 5y times y is 5y squared. And 5y times negative 3 is negative 15y. All right, so now we subtract. That means we change the signs on both pieces. And that leaves me with just 5y squared minus 5y squared is 0. And this leaves me with 15y. Again, we're going to bring down our 25 plus 25. And now multiply. What number can I multiply y by to get to 15y? Just plain 15. 15. So 15 times y is 15y. And 15 times negative 3 is negative 15. Okay. No, sorry, it's not negative 15, it's negative 45. All right, so now we have to change our signs again, and that leaves me with a positive 15 minus 15 is 0. 25 plus 45 is 70. So I actually have plus 70 over y minus 3. So here's my answer. I'll just put it in a different color here. Here's my answer right here. All right, and just like before, we can always check to make sure that we did it correctly by multiplying these two numbers, our dividend and divisor, or our quotient and dividend, sorry, and that is going to be, let's go ahead and put this back in here. So we're going to say y minus 3 times 2y squared plus 5y plus 15. Okay, so y times 2y squared is actually 2y cubed. All right, and then y times 5y is plus 5y squared plus 15y. So I distributed it to the last one also. And then we're going to keep going and say negative 3 times 2y squared is actually negative 6y squared. Negative 3 times 5y is negative 15y. And negative 3 times 15 is plus a negative 45. All right, so when we add that all together, we end up with 2y cubed minus 1y squared. These y's turn to 0 plus a negative 45. Okay, well, I'm looking at this and I'm thinking, okay, it's pretty close. This is almost exactly the same, but here I end up with 25. So I can't forget to look back over here at my remainder, which is 70. So I have to add 70 to that. And in the end, when I do, I end up with 2y cubed minus 1y squared plus 25, because negative 45 plus 70 is a positive 25. And so here I see that my answer checked out just fine. Okay, let's try another one. All right, here's one for you to try on your own. Turn your video off and give it a try. All right, let's go ahead and get going with this. We're going to divide, so let's go ahead and set it up. 3x plus 1. And let's check our exponents to make sure we don't need any placeholders. We have an x squared, we have an x to the first power, and so we have everything we need. So let's go ahead and set that up. 15x squared plus 8x minus 12. All right, so let's take a look and get started. I need to find a number that I can multiply 3x by to get 15x squared. So that's going to be 5x. So when I multiply 5x times 3x, I get 15x squared. And 5x times 1 is going to be plus 5x. Now remember, we have to subtract. So we're going to subtract both terms. And that leaves me with 15x squared minus 15x is 0. So 8x minus 5x is 3x. All right, and go ahead and let's bring down our negative 12. And so now I have to look at 3x and 3x. What number can I multiply 3x by to get 3x? Well, that's easy, just 1. So 1 times 3x is 3x. And 1 times 1 is 1. Again, we're going to subtract, but remember we have to subtract both terms. So we end up with just a negative 13. 3x minus 3x is 0, and that just leaves us with negative 13. So our final answer is going to be 5x plus 1 plus negative 13 over 3x plus 1. Now, that's our final answer, but we always need to check and make sure that we did everything correct. So let's go ahead and multiply the two together. 3x plus 1. Okay, so times our 5x plus 1. And this is simple foiling. 3x times 5x is 15x squared plus 3x times 1 is 3x. Plus 1 times 5x is 5x, and 1 times 1 is 1. Now, we don't want to forget that we also are going to have to add in our negative 13, so I'll just go ahead and put in a minus 13 there. Get all of our like terms together. We end up with 15x squared plus 8x plus a negative 12. And so when I use that and check over here, I end up to see that they're the exact same, so I know I did my problem correctly. All right, one more for you to try on your own. Turn your video off and give it a try. All right, let's do it together. Should be x minus 3. And then we're going to say x squared plus 5x minus 28. What can I multiply to get x squared? Just have to multiply by x. So x times x is x squared minus 5x. Have to change my signs on both of those. This is going to be 0. This is going to be 10x minus 28. So I just need to multiply by 10 now. 10 times x is 10x. And 10 times a negative 5 is negative 50. There we go. Change my signs. That's going to be minus. This is going to be plus. Negative 28 plus 50 is, let me do that real quick on my, let's see, 22. I should have known that. All right, so I have a remainder of 22 over x minus 5. So let's just work it out here. We say x minus 5 times x plus 10. X times x is x squared plus 10x. See, let me get that in there. Okay. Negative plus a negative 5x plus 50. All right, that's going to be x squared plus 5x plus 50. Don't forget my 22 over there. Let's see, that was actually negative 50 plus a positive 22. And that indeed ends us up with x squared plus 5x minus 28. And that one checks out again. Exact same up there, so we know we did it right. All right, yay! Here's an even new simple way of doing division. It's called synthetic division. And this is a shorthand method of dividing a polynomial by a linear binomial by using only the coefficients. Remember, those are the first numbers before our variables. Anyway, for synthetic division to work, the polynomial must be written in standard form. So that's our first key thing that we have to keep in mind. It has to be written in standard form using 0 and a coefficient for any missing terms. And here's the other key part. It has to be x minus 3 or x minus a. Remember, our last problem that we had 3x minus 1, and that would not work because it's not in this form x minus a. So as long as we're in this form x minus a, then it's going to work for synthetic division. The 3x minus 1 would not, because, or maybe y squared minus 1, something like that will not work. It has to be in this format, x minus a. All right, so let's give it a try. All right, here's what we're going to do for synthetic division. And if you'd like to look in your book, you can have this note, make a copy of it, whatever you want. It might help. It's up to you. All right, so step 1, what we're going to do is write the coefficients. So here's our problem right here. 2x squared plus 7x plus 9 divided by x plus 2. So the first thing we want to check is make sure, are we going to be able to do synthetic division? And x plus 2 is in that correct format, so we're going to be able to use it. So step 1. All right, so let's do some dividing using synthetic division. All right, so the first thing we want to do is go ahead and take a look at what our a is going to be. So we're going to look at this piece right here, this x minus 6, and it's actually, the form says x minus a, and so it's in the right form, so a is going to be 6. You could also think what minus 6 is 0, and that would give you the correct answer, which is 6 also. So we're going to set up our table to do our synthetic division. And what we want to do, the first thing we should do is take a look at our exponents. So we have x to the fourth, x to the third, x squared, and x to the first power. So I have all my exponents. So now all I have to do is fill in my coefficients. So this is 1 x to the fourth, so I'm going to put a 1 here. And then I have a negative 3. Next I have a negative 28. Next I have a 59. And finally, I have 6. All right, so I'm going to start my synthetic division now, and all I do is I bring my first one down. The first number is a 1, so I bring it straight down. Now I'm going to multiply 6 times 1, and that's 6. So I'm going to put it in my second column here, and then add. Negative 3 plus 6 is a positive 3. Again, I'm going to multiply 6 times 3 this time, and that gives me 18. So I'm going to put it in this column. Negative 28 plus a positive 18 is a negative 10. Again, multiply 6 times negative 10, that gives me negative 60. Add my column together, I get negative 1. 6 times negative 1 is negative 6. Add those together, and that gives me 0. All right, so next what I want to do is go back and fill in my variables. Now my highest variable in the dividend was a 4, x to the fourth. So I'm actually not going to do x to the fourth. I'm going to actually have x to the third. So I'm going to start out with 1 x to the third plus 3x squared minus 10x plus a negative 1. Now notice here I have a 0. That's where my remainder would be, and I don't have a remainder in this problem. So I can just say that my final answer is this right here. Now, remember, I always want you to check your work to make sure that you did your division and multiplication correctly. So what we can do, this is our quotient, and here is our divisor. And if we multiply our divisor by the quotient, we should end up with the same original dividend. So let's go ahead and multiply that together and make sure that we did everything correctly. So we're going to say, all right, x minus 6 times x cubed plus 3x squared minus 10x minus 1. All right, so I just have to distribute my x first. So that's going to give me x to the fourth plus 3x to the third plus negative 10x squared plus negative 1x. Now I'm going to distribute my negative 6. So negative 6x cubed. Negative 6 times 3 is negative 18x squared. Negative 6 times negative 10 is a positive 60x. And negative 6 times negative 1 is a positive 6. When we add all that together, we end up with x to the fourth plus negative 3x squared plus negative 28x, oops, this one should have been x cubed. This is x squared plus 59x plus 6. So when we check it with our original dividend, it is the same, and we know that we got the problem correct. All right, so let's try another problem. The first thing we want to do is figure out what our a is going to be. So we take a look at this piece. It's what will make this 0? Well, that would be negative 2. So I'm going to start with the negative 2. I'm going to draw my box in. All right, next I want to look at my exponents. I have x to the fourth power, x to the third power, but notice I don't have an x to the second power, so I'm just going to write that over here so it'll remind me I need an x to the second power, x to the first power, and 1. So now I'm going to go ahead and write my coefficients in. I have a 3. Next I have a negative 1. Next I have a 0. Got to keep that in order. And then a 5. And then a negative 1. All right, and I'm going to go ahead and put my squiggly there. All right, so now remember the first step we do is bring our 3 straight down. All right, I'm going to multiply. Negative 2 times 3 is negative 6. Negative 1 plus negative 6 is negative 7. 2 negative 2 times negative 7 is positive 14. Add those together. 0 plus 14 is 14. Negative 2 times positive 14 is negative 28. 5 plus a negative 28 is negative 23. Negative 2 times negative 23 is positive 46. Negative 1 plus 46 is 45. Okay, so now I'm going to go back and put my variables in. Notice I started out with x to the 4 was my highest exponent, so I'm actually going to cut one out, and I'm going to say this is going to be 3x to the third minus 7x squared plus 14x minus 23 plus, and this is going to be 45 over x plus 2, because here, remember, I was dividing by x plus 2 in the end. So this is my 45 over x plus 2. It's actually my remainder. So this is our answer, but I want you to always check to make sure that you did it right. So that you go back and check, we're going to take x plus 2 again, x plus 2, and go ahead and multiply it by what our answer was, 3x to the third minus 7x squared plus 14x minus 23. Notice I don't add my remainder in yet. Okay, now I'm just going to distribute this x to everything. 3x to the fourth minus 7x to the third plus 14x squared minus 23x. Okay, now I'm going to distribute my 2. 2 times 3 is 6x cubed. 2 times 7 is negative 14x squared. 2 times 14 is negative, positive 28 plus 28x. And then 2 times negative 23 is a negative 46. All right, so let's add all this up. And I have 3x to the fourth minus x to the third plus 0, 14x squared minus 14x squared is 0, so I don't even need to put that in. Negative 23 plus positive 28 is plus 5x minus 46, but don't forget I had this extra 45 on my remainder, so I just add 45 in. 46, that's going to leave me with a negative 1 when I add that together. So my final answer, 3x to the fourth minus x cubed plus 5x minus 1 is the exact same thing we started with way up here, and so we know that we did it correct. Here's one for you to try on your own. Turn the video off and give it a try. Okay, so first thing again, we want to look at and figure out what our A is going to be. What plus 3 equals 0? Negative 3. So our first answer is going to be negative 3. It's not an answer. First thing we need. Okay, next we want to look at our exponents. We have x squared, x to the 1, and x to the 0. So we're already in the right order. So let's write our coefficients down. We have 6. We have a negative 5, and we have a negative 6. All right, that's where our remainder is going to be. So now let's bring our 6 straight down. Multiply. Negative 3 times a positive 6 is a negative 18. Negative 5 plus a negative 18 is, let's see, 23, negative 23. And negative 3 times negative 23 is a positive 69. All right. And 69 take away 6 is going to be 63. Actually, negative 6 plus 69 is 63. Okay, so there we've finished right now. Remember, this exponent was a 2, so our new answer is going to be 6x minus 23. And then plus 63 over x plus 3. So here's our answer. And then we can go ahead and remultiply that just to make sure that we did it correctly. X plus 3 times 6x minus 23. So x times 6 is going to be 6x squared plus a negative 23x plus 18x plus 3 times negative 23 is a positive 69. All right, and then let's see, we FOILed that whole thing, didn't we? So now all we have to do is say 6x squared, negative 23 plus 18 is a negative 5x plus 69, but we have to add, let's see, this was a, let's see here, negative 69 here, and we have to add 63 to that. So that leaves us with 6x squared minus 5x minus 6, and that is indeed our original equation, so we know that we did it correctly. Try one more on your own. Turn the video off, give it a try. Okay. So you should again check this and find out what our first number is going to be. So what makes this 0? It's going to be positive 6 because 6 minus 6 is 0. So our first number is going to be 6. Go ahead and draw our box in. Let's check our exponents. I have 2 and then 1, so I have it already in order. My coefficients are going to be 1, negative 3, and negative 18. I'm going to go ahead and draw my line there. Remember, bring our first number straight down and then multiply. 6 times 1 is 6, and it goes right here. Negative 3 plus a positive 6 is 3. 6 times 3 is 18. 18 minus 18 is 0, so we have no remainder. This exponent was a 2, so our first one has to be 1x plus 3, and we have no remainder, so that is our answer right here. And then, of course, we're going to check it to make sure that we're right. So we're going to take our x minus 6 multiplied by x plus 3. And x times x is x squared. X times 3 is plus 3x plus negative 6x plus negative 18. And let's get our like terms together. So we end up with x squared minus 3x plus whoops, that should be a negative 18 right there. Negative 18 because of this negative 6. And so we know that we did our multiplication correctly and our division correctly, so it works out. All right, so this is super amazing. Just kind of blows my mind that this works, but here's the interesting thing about these numbers and problems that we're doing. You can use synthetic division to evaluate polynomials. This process is called synthetic substitution. All right, the process of synthetic substitution is exactly the same as the process of synthetic division, but the final answer is interpreted differently as described by the remainder theorem. So let's just look at the remainder theorem. All right, so the remainder theorem says if the polynomial function p of x is divided by x minus a, then the remainder r is p of a. All right, so what does that mean? So when we look here, remember we were always looking for our a, because to know where to put our number in here, we looked at x minus a. So what number makes this 0? Well, in this case, it's 3. All right, so then when you do your synthetic division, we put our 1, negative 4. Let's see, here's our 1, negative 4. Here's our 5. Here's our 1. Bring our 1 straight down. 3 times 1 is 3. Negative 4 plus 3 is negative 1. 3 times negative 1 is negative 3. 5 times minus 3 is 2. 3 times 2 is 6. 1 plus 6 is 7. So here's our remainder, 7. All right. And amazingly, if we make this the function and say, okay, x is going to be 3, when we fill into this back into our equation, x is 3. it's going to actually end up for 7. And so let's just take a look at that. So we have x to the third, so that's going to be 3 to the third minus 4 times 3 squared plus 5 times 3 plus 1. So 3 times 3 is 9, times 3 is 27, minus 3 times 3 is 9, times 4 is 36. So 27 minus 36 plus 15 plus 1. All right, so I'm going to do that on my calculator real fast. And let's just do that. 27 minus 36 plus 15 plus 1 equals 7. Amazing, absolutely amazing that the remainder is actually the answer when x is 3, which was the number we divided by. So, hope you are thoroughly amazed as I am. All right, so let's look at this example. It says use synthetic substitution to evaluate the polynomial for x equals 2. So the first thing we want to do is write our coefficients of the dividend. So let's just make sure the exponents are all there and in order, and they are. So we're going to set up our 2, and then here is our setup for it. And let's just start our division. So first thing we want to do is bring our 2 straight down. Next, we're going to multiply 2 times 2, and that's going to give us our 4. 5 plus 4 is 9. 2 times 9 is 18. Get it in the right place. Negative 1 plus 18 is 17. 2 times 17 is 34. Add those two together, and we end up with 41. So in the end, we can see that P of 2 is equal to 41. And you can easily check that to make sure. Just everywhere you have an x, you replace it with 2. And when we do that, we end up and see that P of 2 does indeed equal 41. Okay, go ahead and try this one on your own. You're going to use synthetic substitution to evaluate the polynomial for x equals -3. So turn your video off and give it a try. Okay, so I hope you were able to do that. Let's just take a look at the answer. First, we want to write the coefficients out, and then we're going to just start our synthetic division. So first thing we're going to do is bring our 1 straight down. Then we're going to multiply -3 times 1, and that's -3. We add the 2 together, gives us 0. -3 times 0 is 0, so we put that up there. Add the 2 together, we get 0 again. Multiply -3 times 0, we get 0. Add the 2 together, we get 4. So that's our remainder. So amazingly enough, if we just say that P of -3 is going to equal 4, and we can just substitute -3 in place of all of our x's, add it together, and when we do that, it does come out to equal 4. So why don't you just give one more try? Let's take a look at it. All right, here's one last problem for you to try on your own. So turn the video off and give it a try. All right, so this is pretty simple. We're going to start out, and our x is 1/5, so we're going to write our coefficients of the dividend, and there they are. When we multiply, remember the first thing we do is bring our 5 straight down. All right, and so once we've done that, then we multiply 1/5 times 5, and that is 1, so 9 plus 1 is 10. Multiply 1/5 times 10, and we get 2. 3 plus 2 is 5, and that's our remainder. And so we know that P of 1/5 is equal to 5. It's very, very simple. Now we could go back and plug in 1/5 and prove that out. If you'd like to do that on your own, of course, go ahead and do that. And otherwise, that's the end of our lesson for today. So I hope you have a great day, and I will see you in class. Bye.